So, hello, my name is if, right? It's beautiful, it's nice. If something is the case, do something. And we have this all over our code base. But when I'm doing code reviews and I see an if statement, I always look like this. But why is that, right? Why do I not like if statements? So normally we start off with something beautiful and simple with like this, and then we get something, okay, it's else, do something else. And then if something else, if happening something special is the case, do something special. And quite a while later, somebody notices, there's some super rare case that we didn't cover, so we have to do something super rare. And that's the point when somebody comes along and says, we only can do this if something is happening. And at that point, like 2 weeks in, somebody comes around and doesn't even understand what's happening there anymore. And he says, okay, since I don't know what's happening, I just start something down here and it will be fine. So if something special is the case and something else, then do something extra else, right? And the next guy is coming around and saying, oh, he did that? So that's totally fine, I will do this as well, right? And after a while, it's just gibberish. You don't have any clue what's happening in your code, right? That's really terrible. And in kind of to prove my point, we will shortly have a look at opcodes. Does everybody know what opcodes are? Who does know what opcodes are? Okay, that's not everybody, so I will explain it very shortly. If you write a PHP script and you want to execute it, the PHP engine takes your PHP scripts and translates it to opcodes. And those opcodes get executed by the PHP engine and actually went to the CPU to be executed. And so this process from your script to opcodes is actually quite expensive. That's why you all have, hopefully, an op cache or an opcode cache. And what the opcode cache is doing, he's caching the opcodes, so you don't have to create the opcode over and over again. So it's a nice performance boost. But let's have a look at opcodes. So we have some variable. It's true. So let's have a look at the opcodes. These are the opcodes this statement creates, and it starts with an execution statement. The execution statement is an assign. And the thing you're seeing here in the exclamation mark 0 is kind of internal variable name. And then you see the value that gets assigned. And then obviously we return and the script ends. So if we add another variable to this, we can see the opcodes, and it's just another assign. And like I said, the internal variable name now is exclamation mark 1. So PHP is taking your beautifully designed variable names and squishing them down to pure integers, just in order how they appear in your script. And then we're fine. So let's have a look at the opcode of a condition, right? So if condition, echo hello if. The opcodes for this look like this. And the interesting thing is the jump z statement. It says, if something is not true, please jump over me, or jump to a certain point. In this case, we're jumping to the opcode number 6, which is just the end of the script, right? So we're jumping right here. And if this statement is true, then we actually execute what is happening here. It's kind of like goto, right? And internally, it's not PHP specific. Internally, a lot of programming languages are implemented like this. Internally, everything's goto, right? So what happens if we put a not in there, right? It's changing a little bit. So we have this bool not operation in there that's assigning everything to a temporary variable. So the tilde2 is kind of a temporary variable. In the next line, it's using the temporary variable and then doing the jump as requested. Adding an else statement, just the same thing, right? Two jump statements, either to the one that's true or that one that's not true. And then everything gets executed. But not, so conditionals are obviously if and else, but we have switch conditions as well. And if you look at the opcodes, now it's getting quite messy, so I won't hold you to it. You don't have to remember. It's just to make a point in a second. So you see the case opcodes, and then another jump statement. It's just more go-to, right? And it's happening all over. If a special case, then jump to a specific statement. This is quite simple, I would say. But now let's look at the real-time example that we see a lot of in our apps, right? We want to check if some query string variable is set, and if so, we want to assign it to a variable foo in our case. The opcodes for this look like this. So we have, what we are doing is we're getting the value from our superglobal _get. Then we are executing some isSet opcode, and regarding if that's true or not, we are walking through the application, right? And there's another syntax for this. You can use this one, the ternary operator. And when I did the slides, I expected, okay, this should be the exact same opcodes, right? Because it's nothing else, it's just a different syntax. But actually, it's not. So it's quite different. The first part is actually the same, so you're still fetching from the superglobal. And obviously you're doing the isSet, but then there's something different happening. So you have the fetch, and you have like some QM assigned stuff that is doing the magic. So it looks a little bit shorter. That's happening there. And since PHP 7.1, I think, we have the null coalesce operator. And on an application level, it's still the same, exactly the same. But if you look at the opcodes, it's once again completely different. So it still fetches, but then it's getting kind of a new opcode that was introduced in 7.1 in the coalesce opcode, and then you're already done, right? So why do I do these opcode stuff? The thing I wanted to show you is, or just let us compare the opcodes first. So at first, we had the if-else statement. Yes, we had 11 opcodes, and with the ternary operator, we had 10. And with the null coalesce, we had 6, right? So even on a very basic, low level, these if-else functionality, this conditional functionality is handled differently. And the thing is, it kind of looks to me, if I write an if or an else statement, it kind of translates one-to-one into opcodes, right? It's like writing goto. And me as a software developer, starting with basic, so I'm quite familiar with goto, but I hate it. So if-else is quite the same for me. So if I see an if-else statement, it always feels like I write opcodes, kind of. That's why I don't really like it. And so there have to be some different or different ways how we can manage this. And there's another thing that I want to talk about before we really dive into code, is a thing called cyclomatic complexity. Who has heard of the term cyclomatic complexity? Oh, that's quite a few. Cyclomatic complexity is defined as the number of linear independent paths within a section of source code, right? So we can skip the slide and, oh, okay. If we have a look at the source code as an example, we have an entry point into a method, and then there you have like a straight way through your method, right? So this has a cyclomatic complexity of 1. There's one way to execute your method. But if we add an if statement to this, with an else, it differs, right? So now we have like a crossing there. And this actually has a cyclomatic complexity of 2, because there are 2 paths through your application now. And if we increase the if and else statements, we will get something like this. It's even worse, right? Anyone want to guess what the cyclomatic complexity of this is? 4? It's 3. Don't really ask me why. I tried. It's really hard to explain, and I had to read the Wikipedia article like 10 times to understand it. But I give my best, but don't worry about it. It's not super important. So you have this way, right? That's number 1. You have the other way around on the bottom. And then you have this way. And if you're looking at it from an execution point, the other way isn't possible anymore. It's really hard to get this from slides and me talking to you. Just give it a try at home and try to fiddle around with it. Yeah. So this has a cyclomatic complexity of 3. And now imagine that we have something that executes, we are writing unit tests, of course, right? Everybody of us writes unit tests. And now we have a unit test that is testing the if part in the first statement and the if part in the second statement. Then we have a unit test that is testing bar in the first statement and buzz in the second one. So now what we have is we have like 100% code coverage, right? Every statement was executed during our unit tests. But if, for example, fizz is depending on something happening in foo, then we could have a problem, because if bar gets executed and then fizz, then everything will go to shits, right? And even if you have 100% code coverage in your application, it doesn't mean you have tested everything, right? Because there are different paths through your application, and you have to test every path that's there. So what can we learn from this cyclomatic complexity thing? The thing is, a module should have at least as many tests as its cyclomatic complexity. So let this sink in for a second. So we have a metric, cyclomatic complexity, and that tells us how many unit tests we should have. That's quite nice. So what we should try to do is to keep our cyclomatic complexity low, so we have to write less unit tests, because who want to write unit tests, right? But what's the root of all evil for unit tests, for cyclomatic complexity? You guessed it, it's conditionals, right? So everything we do, like if, else, switch case, they are all increasing our cyclomatic complexity. But so they are kind of bad, but they are part of the language, right? And how should we do it otherwise? Because if you look at the keywords of the PHP language, they are right there. So they are there to use, right? There's switch, if, else, else if, case. But if you look at the keywords of a different language, for example, Smalltalk, they have only these 5 keywords. No if else, no switch, no case. Okay, but but how would that even work, right? So no if, no else, how could I even do something, right? And the thing is, Smalltalk comes from a sweet little world where everything is an object. So we have objects everywhere. And I will try to explain this in PHP code, how it works in Smalltalk. We have an object that has a method. And in Smalltalk, everything is an object. So there are no primitives, right? It's kind of like in JavaScript, because as soon as you put a string there for JavaScript, it's an object. And for Smalltalk, it's quite the same. So you can just define something, and then it's immediately an object. So you have a string, and you can call a method on it, like append some other text. What's happening internally is we have an object, some text, and we send a message to it that's called append, and we are passing some arguments to this method. So if you're looking at this, it's 1 plus 1. In an object-oriented programming language, it would look like this. We have an object 1, and we are calling the method plus with the argument 1. So we have an object, we're sending a message to it with the argument. And that's the same is true for comparison operations. So if we have 1 equals 1, in an object-oriented world, we're calling a method called equals on an object 1. So same thing. But what should this thing return? Right? That's the big question. That's why Smalltalk is special. And Smalltalk is returning something that is called Boolean class. And if we would implement something like this in PHP, it would look like this. We would have an interface, Boolean class, with 2 methods. The first one is if true, and the second one is if false. And if we would implement the interface, we would implement true class, and we would implement the if true method, and execute the closure that is given to us. And if false, we would implement like, don't do anything. Keep in mind, we're returning this. It's getting important a little bit later, but don't worry about it now. So, and of course, the false class is just the other way around, right? If true, we're doing nothing, and if actually false, we are executing the closure we are getting. Now I'm cheating a little bit. So let's say I have implemented those 2 classes, and I have a thing that's, if I call evaluate condition, it's returning one of those objects. So now what I can do is I can say, yeah, now I get a Boolean class back, so I can do something if true, and since I always return the object itself, I can also run if false on it. So I can put some code in here, a closure, and a closure in here, and now the if statement is gone, right? Awesome. If we would adopt this to our PHP code we've seen before, right, to this one I showed before, it would look like this, right? We would change to the condition stuff, and then do it this way. This way, the cyclomatic complexity would go down by to 1. There's only one way to execute your method, because everything gets executed all the time, right? Awesome. So cyclomatic complexity of 1 unit test, right? No. No. Please. I know it looks nice, but it's actually really crap. Because what it does is it's hiding the cyclomatic complexity from you. The cyclomatic complexity is still there, but it's completely hidden now. You have no clue, right? So you have no clue how many unit tests you have to implement to test this. So you have to keep everything in your head. You have no support anymore. So if and else statements aren't that bad, right? Kind of. Who of you know cutters and is doing cutters in a regular fashion? So cutters are, I call them training problems or puzzles that you can solve in your free time. Most of the time they are about a very small problem with a very specific goal. You get a small exercise, you get a chunk of code, and then you can work with the code and improve the code. And one of those cutters I want to talk about is the Gilded Rose cutter. So if you want to do this at home, just Google Gilded Rose cutter and you will get some similar source code I will show in a second. So the Gilded Rose cutter is actually about a company that is selling roses. And all the roses they have a name, they have a quality, and they have a sell-in date. So it's like buying milk. In some time they are going bad. They are decreasing in quality, and so they have to be sold at some point. And this is actually the implementation, right? And this is only the first half of it, so here's the second one. So we have like a 40-line if statement here. Great, awesome. And when I look at it, and I'm collecting all the data of it, and it has a C.R.A.P rating of 23. C.R.A.P rating is a metric that is most of the time based on cyclomatic complexity. It has some additional stuff in it, but most of the time it's telling us the cyclomatic complexity. So this 40 lines of code have a cyclomatic complexity of 23. So 40 lines of 40 lines of source code, 23 unit tests. Okay, awesome. So this code has actually 16 if statements, 7 not equals, 2 not equals and functionality, 3 magic strings, and a lot of numbers. The magic strings we are talking about are HBRE, backstage passes to whatnot, and Sulfuras, hand of Ragnaros. And thank God, we have tests. Awesome. So if we execute our unit tests, they actually pass. Great. But there's something strange here. We have 4 skipped unit tests. So let's have a look at the unit tests, what this is all about. So when we look at the unit tests, they kind of cluster around the names we were seeing before, like HBRE, Sulfuras, backstage. The unit test also mentioned something called normal that was never mentioned in the code. Okay, maybe we figured it out later. And if we have a look at the one of the unit tests, it actually just creates the Gilded Rose with a name, the quality, and a sell-in, and then it calls the tick method. And the tick method is called every day to calculate the new values of your roses. And so if called once, the quality should go down by 1, and the sell-in date should go down by 1. Okay, that's fine. And now let's have a look at the unit tests that are skipped, and they all cluster around something that's called conjured. And now it's getting quite obvious. The cutter wants us to implement conjured. And this is kind of, no, please. because 40-line if statement, they want me to implement a new rows into this. No. I tried, I really tried. And I failed miserably. So I decided, let's do a completely different approach, right? What I wanted to do is, I say, okay, what here has to be something called normal. It's not mentioned in the code, but if something normal is happening, so if we are calculating something for the normal rows, we will just stop and do nothing. And then we should execute the unit tests, and we would hope that every normal unit test would fail. And luckily, all the unit tests for normal fail. So we can be quite certain that we caught all the paths for our normal rows. And now, since I don't want to add any more source code to this 4-line if statement, I just create a new function, tick normal, or new method, call the new method, and once again stop execution. Just to be safe, execute the unit tests again. Okay, still all normal tests are failing. And now, what can we do? Have a look at the unit test. So quality should go down by 1. Okay, let's do this. Sell-in date should go down by 1. That's easy as well. Okay, great. Let's execute the unit test as well again. So one test is already running again. Great. So next one. If we have, in this case, we have the quality going down by 2, and this is regarding to the thing, if the sell-in date is already 0, then the quality degrades twice as fast. So, okay, we put an if statement around it and say, if sell-in date bigger than 0, we just decrease by 1. On the other hand, we decrease by 2. And okay, unit tests. Oh, 3 unit tests are already passing. So we won't even look at the third one. We just skip it because it's already running. Who cares? The first one is, it's telling us that the quality is staying 0 if it is already 0. So what we do is we just add another if statement. If the quality is not 0, then we do all the stuff, and otherwise we're done. And great, everything is working again. We're back to green, and that's very, very important. That's the place where you want to be, right? You may wonder, okay, Sebastian is talking about how awful if and else statements are, and he's writing the worst code ever, right? And yes, that's true, but I don't care. I want to be at this point. I want to be at the green light. Because if you do a refactoring, it's super important that you get as fast as possible back to this state. If you change something in a not green state, when your unit tests are not passing and you're changing something, you have no idea if the stuff you changed was really affecting that unit test or it did not. So the first thing we have to do is to go back to green and then start optimizing our refactoring. But like I said, this is kind of ugly still, so let's optimize that. So what I'm trying to do when I'm writing code is kind of telling a story. Like, if you read code from top to bottom, it should be like, not like a poem, but like a story. It should tell you what happens. And in our case, what's happening all the time is the decrease of the sell-in. That's done all the time. So we put it right on top. Stuff that is always happening on top. So then we have the thing, if the quality, blah, 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 it must be greater than 0, I would do it this way. If the quality is equal to 0, then we don't have to do anything anymore. because the selling is already done, and we don't have to change the quality. And this looks very simple, but early returns are one of the major powerful tools to avoid endless nesting if-else statements, right? So early returns are really, really powerful in that regard. And next, we could argue that we sometimes decrease the quality by 1, and sometimes we decrease it by 2. I would tell it a little bit differently. I would say we always decrease the quality by 1, and sometimes we decrease the quality by 2. So that's basically what we came up with. And now it's kind of storytelling, I would say. Just to be sure, run the unit tests again. Everything passes. Awesome. So now that this is our code, right? We have the tick normal method. Next up, what we would do is, of course, continue with the next rows, right? And this is like the HBRE rows. So what we do is we create a switch case statement. Ignore the crappy code first. We want to go to green, right? Create a new method, HBRE. And of course, we run our unit tests to make sure that we catch all the executions. So all HBRE tests should fail. And luckily, they do. So we can implement the method in the same way we did before with the normal one. And then we come up with something like this. And now something really dangerous is happening. So you can see stuff, right? We particular as developer, we are very good in recognizing patterns. If we see something and something quite similar, we immediately catch on to this, right? We say, oh, this looks the same, right? And it's in code, it's quite similar, right? We see something that looks similar, and we say, maybe we can do something with this, right? And so we can go on a sidetrack and do a completely different thing from the thing we were intending to do, and we shouldn't do that. Please don't do that, because the thing is we are only refactoring the second method now, right? And there are a lot of roses to come, and so we know like 50 or 40% of our application, and maybe the decisions or the clues we're getting right now are completely wrong. So please don't go on the sidetrack. Try to focus on the task at hand and accept the duplication for now, okay? So we don't bother about that the two methods look the same. We just continue with our journey, right? Now we're looking at the sulfuras, right? And what we do is we add something to the switch statement. We create a thing, and what? No unit tests is breaking? Oh, that's bad. That's really bad. So let's have a look at the unit tests, right? So the unit tests are telling us that the quality stays the same and the sell-in date stays the same. Okay. So this actually is the code that makes a test pass. Awesome, right? Okay, next. So let's have a look at the last one, the backstage one. Once again, we're creating the method, and we come up with something like this in the end. It doesn't really matter right now. And if we execute our unit tests again, everything passes again. That's quite nice. So if we look at our code, that's our code. And now, since everything is running again, we can take our 40-line if statement that was still there, and we can give it to Oscar, right? We can move it to trash. That's always the most satisfying part in software development. Just throw code away. And if we look at our metrics in our C.R.A.P rating, so the big conditional had a C.R.A.P rating of 23. Any guesses how our C.R.A.P rating improved? What's our new C.R.A.P rating? Okay, it's 20. All the fuss for 20, for 3 points, come on. But it's kind of misleading, right? Because the worst part of our old software had a cyclomatic complexity of 20. That was the 40-line if statement, the method tick. Now, the most complex stuff in our application is like 7. That's quite nice. And that's quite a bit improvement, I would say. And then you ask, why isn't everybody doing this, right? And I have a guess, because if you look at the C.R.A.P rating during our refactorings, right? During the process we did, we started with a big conditional, then we added a method for normal, then for hbree, then for sulfuras and backstage and that stuff. And our C.R.A.P rating steadily increased and increased and increased. So our code, if we believe our metrics, got worse and worse and worse. And normally that's, oh, no, you have to stop doing this because our code quality decreases. We can't have this. Please stop. And yes, that's kind of true. But if you're doing refactoring, you have to trust that what you're doing is right, that there's light at the end of the tunnel, right? So you have to walk towards the light, at least doing refactorings. Because in the end, when our refactoring was done, we actually did improve a lot. So we have this intermediate complexity during our refactoring processes. Because sometimes to make stuff easier or to improve stuff, we have to do weird things. And we will see this in a second. So the cutter actually wanted us to implement conjured, the new rows. So this is our code right now. And should we do this? We could add another method, take conjured, and it's fine, right? It wouldn't be too hard. But I would argue that we shouldn't do that. Like I said, if we as a developer see code, we kind of try to emulate the behavior of the code or the implementation style and continue in that way. And I would argue that adding another method is still a bad way of doing stuff. Because if you see something with a prefix or methods with a prefix or a suffix, it doesn't matter, it's most of the time a little puppy that wants to get out, right? It's saying, please let me out of here. I'm trapped in this object. So what we want to do is we want to create, we want to let the puppy out, of course, and what we have to do for that is we have to create some new objects. So normally what this means is that every method with the same prefix should be an object for its own. So let's do this. So for the tick normal method, we create a normal class, and then, of course, we still have to worry about the quality, the sell-in stuff, so we create a constructor, and then we still have to access the quality and the sell-in date. Okay, great. Now what we can do is, in the tick normal method, we can just create a normal rows and call tick on the normal rows, right? But now we actually have a problem, because now, since if we look at the gilded rows knows about quality and the days remaining stuff. And now we have hidden this stuff in an own class. So what we have to do now is we have to do a workaround, right? So we have to store the rows somehow to add a property for the gilded rows, and then we have to say, okay, if we have a rows, then we ask the rows for the quality, and if not, we will use the quality I know of. And the same thing is happening for the days remaining, right? If we have a rows, then use this one, and that's the same thing, right? We're just increasing complexity. It's getting really weird. So, but yeah, we have an idea. We want to go somewhere, and we think this is a good way. So trust in ourselves, and it will work out in the end. So we're doing the same thing for all the methods we have. So we're doing the HB thing, properties, constructor, setter, getter. Then we in the tick HB we just create the object and execute the tick method again, and then tick sulfuras. Okay, great. Object, constructor, properties, setter, getter. And now people really get suspicious, because before we had like 0 lines of code, and now we have an object with like 15 lines of code, right? And this is a really simple example. This can get really, really messy. So they are always tempted to not do this because it's not feeling right. But like I said, we have to trust that there's light at the end of the tunnel. So let's do the same thing with the backstage thing. Create an object, create properties and a constructor, create the getters, and then actually do the stuff in the tick backstage method. What we can do now, since we always have rows, we can clean up stuff, right? We don't need the name anymore. We don't need the internal quality and cell in. We can just remove those. We only need the rows. And since we always need one, I just moved the code from the tick method to the constructor and said, okay, I'm always creating the right rows if we create a gilded rows object. And in this way, we can actually simplify the getters again, because we always have rows, so we only ask the rows for the quality and the days remaining. And our tick method gets really simple. We only call tick on our rows object. Now, we still have this ugly switch case statement, right? So, and I hate conditionals, so we should do something about this one as well. So, what this switch case statement actually does is it is creating objects. It's just creating the right type of objects for us. And that sounds familiar. So there's actually a pattern for that. It's called factory. So let's use an object factory for that, right? We create one that is creating our rows, our roses, and then we can throw all that stuff away, and we can just call the rows factory and say, please give us the rows we need. And to make sure we really get a rows and all roses behave the same way, right? We should define an interface. So we have an interface rows with all the method we need. And then we can actually add a cool return type to the factory method, and it's cleaned up very, very nicely. So now we have these methods, these objects, normal, hbree, sulfuras, and backstage. And now is the point that we really know what our application is doing. We understand what the business is doing. We know what the tick method does and how the application actually operates. So now it's time to get rid of the duplication, right? Now we have a clear picture of everything, and we can safely say, okay, they all look the same and they are the same. That's very important. So what we actually can do is we create a base class for all the roses, like a class rows with all the properties and the constructor, setters and getters. And of course, we make sure that every rows will implement the tick method as well. So What we can do now is we can go to our normal classes, we can extend the rows class and throw everything out other than the tick method. We can do this for hbree as well, of course, and the sulfuras. And now it's looking again like an empty method, right? We still have a class for it, but it's not as bad as it was before. And of course, backstage as well, right? And now we have cleaned it up quite a bit, I would say. So, C.R.A.P rating. First one was 23. The second one, with the methods, we had 20. Any guesses what our C.R.A.P rating is like now? 13, I heard 13, that's not bad. Any other guesses? So it's actually 17. Woo! And that's kind of the thing, right? Your application has a kind of complexity, right? And you can't take every complexity out of your complete application because your application has still to operate and has still to do all the complex stuff. But what we did is we actually decreased the parts that were very complex. We started with 20, then we actually went down to 7, and now the most complex part we have is a 5, and that's hidden somewhere in I think it's the backstage rows, right? So the backstage rows now is the most complicated part of our application. That's quite nice. So everything that's happening in front, the business logic, that's very simple. It's totally clear to understand. And what we actually achieved here is we decreased the complexity about 75%. That's quite a lot, I would say. So now what? So we still have a task at hand, right? The cutter still wants us to implement conjured. And now it's super simple, right? We just create a class, implement the tick method, so the unit tests will pass. Obviously, we have to make our factory able to create the conjured, rows, and then we have to remove all the skipped tests. And now we're kind of done. Everything's working, right? Super nice. So what should we take away from this? We should choose duplication over the wrong abstraction. If you start abstracting stuff early without the whole knowledge about your whole application, it's quite dangerous. Because getting rid of duplication is most of the time very easy. But getting rid of the wrong abstraction is really, really hard. If you have an entangled object architecture, to get rid of this is really, really hard in your application. But duplication is most of the time very easy to handle. Next thing is solid. I think you have heard of it, especially the O in solid. The open-close principle. The open-close states, be open for extension, but closed for manipulation. And that's exactly what we did, right? Our gilded rows, our application that's executing our business logic, is open, but so you can add different roses to it. You can just create new roses and add them to your product line. That's no problem. So you're open for extension, but you are closed for manipulation because nobody can interfere with the business logic inside. The tick method is getting called no matter what. So, and you have to implement the tick method in a way. So the way is up to you, but it has to be implemented. So this is always a nice thing. You have to be open for extension, but closed for manipulation. The big takeaway is build small things. If you build small things, then it's much easier to test them. It's much easier to wire them up. They are much easier to understand, and they are much easier to maintain. And don't fear the the intermediate complexity. So if you do refactoring, stuff sometimes gets ugly, and it's getting more complicated. But you have to trust in your idea and in your skills that you know, okay, I know we have to do this workaround, but in the end, it will improve massively, right? So don't fear the intermediate complexity. I want to end with a quote. Since I'm a Apple fanboy, I'm ending with a quote of Steve Jobs. He said, "Simple can be harder than complex. You have to work hard to get your thinking clean to make it simple. But it's worth it in the end, because once you get there, you can move mountains." And that's kind of true for software development as well, right? He was talking about UI and all that stuff, but it's true for software development as well. Sorry. Kent Beck, one of the authors of the refactoring book, said it a little bit differently. He said, "Make change easy. This might be hard, and then do the easy change." And that's exactly what we did for the last 50 minutes. We worked really hard to make change easy. So we did this 45 minutes, and then we did the easy change by implementing Conjured. And that's how you should do it at best. And then you live happily ever after. Thank you very much.
Thank you, Sebastian. We have about 7 to 8 minutes for questions. And the first one that we got through Slido was, does less OP codes mean faster execution time? Do OP code execution times vary and after performance?
Yes, they do. So not every opcode executes in the same way. So less opcodes doesn't mean more performance. Let's say it this way, less opcodes of the same opcode is definitely a better performance. But you can have different opcodes, and sometimes it's more efficient to do 5 opcodes than 1, because one is more memory intense or something like that. But that was more like a mind exercise to get you into my conditional hatred, right? You don't want to write opcodes, and that's kind of my thing to explain why I don't like to write if statements. It shouldn't be on your mind to improve the opcodes, because as soon as you have 10 classes, you can't see anything anymore in your opcodes, because there are so much of them. So please don't try to optimize opcodes that much. Yeah.
Okay, next question. What is desired code complexity?
Oh, 1. But it's not possible, obviously, right? Since we have to make decisions, we have to do what the business requires, and the business always tells us, do this in a certain way, if something special is happening or something. But so some complexity isn't avoidable at all, but you should arrange it or build it in a way that it's easy to comprehend for all your developers, I would say.
Okay, third question. How do you measure C.R.A.P score?
That's quite easy. If you execute PHP unit and do a code coverage report, it actually puts out it creates an HTML website. And if you open the HTML that PHP unit generates, you can have a look at the C.R.A.P rating.
Next question. Does less cyclic complexity mean faster execution?
Not necessarily, but it means faster execution in your mind. So it's much easier to understand what the code actually does if you look at it. Actually, no, it's not improving performance at all, because if you have like an if statement with 40 lines in it, you only execute one path. You don't execute everything of it. So reducing that stuff isn't really improving performance. It's just about keeping your sanity.
Are there any tools for checking C.R.A.P?
Like I said, if you execute PHP unit and create a code coverage report with Xdebug, then you can actually see the code coverage and the cyclomatic complexity and the C.R.A.P rating.
What about performance costs and time to implement?
So yeah, if you
It's completely a different lecture.
yeah, so
Why so nervous?
no, it's if you have code that never changes, you can write it as dirty as you want. I don't care, right? If you write it and you write once, own it. Yes, I wrote dirty code. That's awesome. But if you're developing in a team, then the cost of writing crappy or hard understandable software is much higher than the implementation time of cleaner code. And that's what you have to make your business understand. So if you write cleaner code, that may take more time, but in the end, you gain a much more performance during the development process.
Okay, and the last one. How can we see opcode's output? Is there some tool for that?
Yes. Derek, the author of the Xdebug extension, has actually an extension for PHP that can output the opcodes. That was what I used for the slides. It's called the Vulkan Language Dissembler or something like that. If you go to the Xdebug site, there's actually a link to the extension as well.
Thank you, Sebastian.